Okay, without further ado, you guys have been incredibly patient. Let's introduce Jonathan Carr from Lyra. Thank you.
Hi, my name is Jonathan Carr, and I'm in charge of engineering and design for all the products that Lyra makes. Although Lyra is a cartridge manufacturer, Stig and myself are personally format agnostic. I grew up in a household with 3 pianos, 2 of which were pneumatic reproduction pianos. Tons of 78 RPM records as well as 33s, reams of musical manuscripts and art books and things like that, and no TV. So all of this taught me the value of our cultural heritage, and this is something that I consider to be essential to protect and preserve for the next generation. So this is really what we are trying to do, to pass on the cultural heritage that our ancestors made and give it to the next generation so that they may build on it. Now, I'd like to have this conversation. This really should be more like a conversation rather than a one-way presentation. So if you have any questions, please feel free to inject at any point in time. It was really interesting for me to listen to Bernie's presentation earlier because there are so many parallels with, at least the emotional content of what he's trying to do with what we do. Although the technical aspect is important for our role as reproducers rather than producers, at the end of the day, we listen to what we make, and if the emotions are flat, it just doesn't work. So for us, it's most important to convey the emotional content, the emotional message that the musicians on the record are trying to convey. And I would say that, if you know a piece of music, for example, by Beethoven or Mahler or Richard Strauss or whatever, you can go through books about that composer at a given point in time when he wrote that piece of music and see what he was going through and try to extrapolate what sort of emotions were behind that piece of music. But in the absence of that kind of musicology research, I would suggest that what you're looking for is the widest range possible of emotions in the reproduction that you have in your system. So that, I would say, is the most valuable to us as human beings, and that would be the goal that I would certainly aspire to. Now, when it comes to the technicalities of cartridges, there's moving magnet, there's moving iron, there's electrostatic, strain gauge, moving coil, etc. We've been listening to, for example, induced magnet or moving magnet cartridges from the 1980s, and we've never stopped listening to these. So we respect that there are any number of ways to reproduce a record in high fidelity. So although we choose to do moving coil cartridges and we choose to focus our efforts on the LP, we respect that some people may prefer digital, some people may prefer moving magnet. It's all cool. Technically speaking, what we are trying to do with a cartridge is to measure what's inside the groove. And with a moving coil cartridge, the cartridge itself is fundamentally a generator. So it generates signal in proportion to the energy that is inside the groove. And it does so by using a diamond stylus, which is at the end of an extended rod, which is called a cantilever. And the stylus follows the shape of the groove, and it is leverage reduced by the length of the cantilever. and that moves a piece of either plastic, ruby, or iron, which is usually called the armature. And there will be a coil wrapped around the armature, and this moves inside a magnetic field, and this is what generates the signal. A lot of what we do as cartridge designers is to deal with the peculiarities of the electromagnetic generation process. So, a lot of problems are inherent in the electromagnetic generation system. There are a lot of nonlinearities, there are a lot of losses, and all of these we need to factor into the engineering that we do. One thing to keep in mind is that almost all electromagnetic transducers, whether they're speakers or cartridges, are horribly inefficient. There's a hell of a lot of energy that is lost. There's a lot of excess energy that is created and used for no good purpose. For example, the most efficient loudspeakers that we know of are compression horn drivers. And the highest one that I know of has 116 dB efficiency. But even that, at 116 dB, that's only 50% efficient. 50% of the electrical energy that goes into a 116 dB efficiency loudspeaker is wasted as heat. And the same applies to phono cartridges. But in a cartridge, we don't have the weight budget to install huge, heavy magnets. So our efficiency is much less than 50%. I would say that most moving coil cartridges are operating on the order of probably 5% efficiency or less. So therefore, 95% of the mechanical energy that enters the cartridge, it doesn't do anything except rattle things around. So a lot of what we do as Lyra is to think of ways to deal with that excess energy and quickly get it out of the cartridge to a place where it is likely to do less damage to the reproduced signal. In a cartridge, if there's a lot of stored energy inside the cartridge, due to its proximity to the generating mechanism, there is an echo effect going on. So the energy that enters the cartridge, the 95% energy, if you don't deal with that energy properly, it will reflect back into the generator mechanism and create a reflected version of itself, which may be pleasant to listen to, but it's probably better to be, if it weren't there. So therefore, we've taken the approach of extreme rigidity in our designs. We mount our cantilevers directly to a solid metal body structure, and we try to focus on mounting that structure as tightly as possible to the tone arm head shell, so that energy can be dumped into the tone arm and brought into the plinth of the record player, where there is just a whole lot more mass to deal with that kind of energy. When the mechanical signal enters the stylus, it goes into the armature and the coils, and that forces the coils to move. And with a moving coil cartridge, there will be two magnets or a single magnet split into two poles by virtue of parts that are called yokes or pole pieces, same thing. Now, one will have the north polarity and the other one will have the south polarity. And when the armature moves, the iron content of the armature creates a low impedance path for the north to south flux, magnetic flux, to flow through. And when the armature flips in the opposite direction together with the signal in the groove, the same process occurs in the reverse direction. But what is important to note is that this is all magnetic attraction rather than repulsion. And with attraction, the closer the iron approaches the north and south poles, so you have, again, north, south, and armature angling in between, the more strongly it is attracted to the north and south poles. And this is equivalent to cogging in a motor. And so to get it to, so it wants to be attracted more intimately to the north and south. And so you have to extract more and more energy from the groove to get it to unstick and head back in the opposite direction. So if you have a cartridge and vertical tracking force is applied, in most cartridges this will cause a preset angle to occur between the armature and the north and south magnetic poles. And so you have a built-in sticking effect going on in the basic structure. So Lyra's approach for maybe close to a decade now has been to build in a reverse angling system into the suspension and the dampers, so that when vertical tracking force is applied, the armature goes back to a perpendicular position rather than an angled position. And when we do that, we find that the armature is more free to move in all directions with equal ease because it is equidistant from either north and south when vertical tracking force is applied. And this gives us much better, this gives us a wider range of dynamics and better tracking performance. Now, my role is to engineer the cartridges, but as Bernie was saying earlier, in these mechanical transduction systems, everything counts. And we find that the human element, in other words, the builder, is also a key factor. So although I do the design, a Lyra cartridge would not be a Lyra cartridge if it were not for the decades of experience that Mishima Yoshinori has. And he is the person that builds all of our cartridges. And actually, the sound of our cartridges is determined by him, not by me. So his aesthetic judgment plays a very, very important role in how Lyra cartridges sound. His background is as a studio engineer. He worked in a recording studio, and so he brings his own experience or intimacy with recorded sound into the reproduction process. So one of the things with engineering, audio engineering, is that, as Bernie was saying earlier, the numbers don't always line up with the audible experience. And it really, as experience builds up, you really start to find that some of the things that you thought were important are less so. And other things that you thought were of piddling importance really turn out to be quite important. And one of the things that I would argue is of not that much importance at all is the frequency response. Due to room nodes and due to the directivity of sound, if I move, the frequency response of my voice to your ears is inarguably going to change. But do I sound like something else? Do I sound like another person? Do I sound artificial? No. When we speak in daily conversation, our ears are hearing shifts in frequency balance all the time. So yes, frequency response is measurable, but it is something that our ears have learned to adapt to on the fly over tens of thousands of years. So this is one of those factors where you wonder, we listen to the sound of live voice, live music every day, and we aren't bothered by this. So why is it that frequency response is so emphasized in reproduced sound? So what we find is that it's more likely to be the dynamic range, which is key to how well a musician expresses himself or not. If the reproduction system compresses the sound, the performance is likely to sound much more polite than what the performer intended. And this is something that you cannot recoup with an equalizer or any other mechanism. Once it's gone, it's gone. So we listened with our ears, and we try to focus on the aspects that are likely to convey more of the emotion in the music. Any questions so far?
You see, you have one guy that makes everything.
Yes, he's the third member of our party who is absent today.
I subscribe to most of the audiophile publications, and often I see Lyra cartridges in various retailers' ads. One guy, it looks like you have a whole line, and everybody's advert. One guy makes all the stuff.
Well, what we find is that different stages in the manufacturing process show different sensitivity to the final sound. And so the early stages of the manufacturing process are not that important to the final sound. And so those areas we actually have given over to apprentices who we hope will take up Mishima's mantle once he gets, once he gets bored with building cartridges. But the final stages, so the closer we get to the final stages where damper, compression, suspension, tuning, etc. is involved, then you're much more likely to be in a realm where what is physically done to the cartridge is reflected directly in the final sound. And so we increase our manufacturing capacity by having apprentices take care of the earlier stages of the manufacturing process. And we let Mishima focus on the final stages of the process where his input is, as I said earlier, without it, it would not sound like a Lyra. So our manufacturing capacity is about 1,200 units yearly. And that includes all models. We have to be very resourceful in how we use Mishima's time and energy.
Yeah, you talked about specs that are important that we should focus on, and specs that are not important.
Yes.
Can you maybe talk about some of the specifically talking about cartridge setup? Maybe explain things that are important that we should pay attention to, or maybe demystify what's not important.
Sure.
We've been told that vertical tracking angle, that's so important, or Stylus rake angle, or azimuth, or all these different things that you should check when you set up a cartridge. In your opinion, what's the most important things we really should focus on to get the best sound?
I would first say that horizontal tracking error is not very important at all. There are tone arms that are normally referred to as pure straight arms, and these have no offset angle whatsoever. But they sound great. They sound really, really good. Now, again, if we were so sensitive to the horizontal tracking error, then we should be horrified at the sound of a cartridge tracking on a tone arm that has no offset angle. But in reality, though, such arms actually bring things to the party that offset angles are not able to do. And so, again, the problem with with offset angle, as far as I'm concerned, is that a sideway force is generated and the energy for it is taken from the groove. But then you have to apply more force to compensate for this in the form of anti-skating. So you've kind of double lost energy. And when you listen to a pure straight tracking arm, the sound is a lot more dynamic. Now you could say that the sound is a bit fuzzier at the end of the groove, and that's probably true, but which is more important? So again, we need to not just look at the numbers, we need to use our ears and say which is more important for the total performance that we're trying to reproduce. So I would say, there's also Stevenson tracking curve. There's the Bierwald, there's the Lofgren, there's the pure straight. There are so many competing standards for horizontal tracking error. And, with that range, how can you say that one is the best? So, I would say, go with whatever your tone arm manufacturer says is best, because when you design a tone arm, ideally speaking, the vertical bearing should be placed at the same offset angle as the head shell. So you probably want to go with whatever the tone arm designer had in mind, because if you don't observe the same angle, then you'll be introducing azimuth errors as the cartridge goes up and down, and that's probably something that you don't want to do. One thing that I feel is important in tone arm, in cartridge setup, is to keep the same tracking force all the time. And this means almost automatically that the vertical bearing must be placed in the same plane as the stylus. So even if VTA is raised or lowered, the vertical bearing of the tone arm should always be in the same plane as the stylus. How many tone arms do this correctly? Almost none that I'm aware of. And when the bearing is not in the same plane as the stylus, first of all, the effective length of the tone arm changes as the cartridge goes up and down, and the vertical tracking force also changes when the cartridge goes up and down. And to me, this is something that I would prefer not to happen. So I would much prefer to see a tone arm that was, it didn't really focus so much on the horizontal tracking error, but it paid more attention to keeping the operating conditions for the cartridge uniform, even when the cartridge was moving. Then also, of course, there's the thing about anti-skating. So if the tone arm has an offset angle, what is the best way to apply anti-skating? And there have been various string and weight and springs and whatnot. And all of these affect the sound. So, you have to find the compromise that works the best.
I received a few questions
Fire
from some customers that couldn't make it.
Sure.
The first one is regarding the mono cartridges, and I'll read from it. What advantages do Lyra mono cartridges, like the Etna Mono, have over similar Lyra model stereo cartridges running through a mono summing circuit on a phono preamp? If one is using a Lyra mono cartridge, would there be any benefit in also running it through a mono summing circuit? And then in addition, he writes, traditional mono cartridges are constructed with zero vertical compliance without regard for their potential for damaging stereo records. Can you compare the design benefits of a Lyra mono cartridge to a traditional mono cartridge?
Sure.
This is a gentleman that ironically just ordered a an Etna mono. So
Okay, so he wants reassurance for his purchase. I understand that. Okay. A mono record is cut horizontally only, so there's no vertical component in the signal whatsoever. So any vertical component that comes out in the sound is almost certainly going to be an error. So what you want to do is to make sure that there is no electrical sensitivity to vertical components in the groove. Whether the stylus moves or not is, in my opinion, completely immaterial. The key is to make sure that there's no electrical response generated even if the stylus moves. And by allowing the stylus to move, of course, the cartridge becomes a lot more friendly to a whole range of records because, we speak of damage that mono records can inflict, mono cartridges can inflict on LPs, but mono LPs are also made from PVC. The material is one and the same. So why should we be so sensitive to what a mono cartridge does to a stereo PVC record, and yet be so cavalier to what the same mono cartridge may be doing to a mono LP made of the exact same material? So in my opinion, it's much better to build in some vertical compliance into the cartridge so that the PVC, whether it's stereo mono, is not stressed. And we do our mono reproduction by putting two equivalent and equally oriented coils. So both are oriented so that they can only respond to horizontal signals on the LP. So even if there's a vertical component in the groove, whether it's noise or damage or a pressing defect, the coils, due to their orientation, are incapable of generating any signal in response. And this leads to a much better signal-to-noise ratio. It also gives a much more solid sound to the proceedings because you don't have this diffuse noise going on to distract from the primary signal that you're trying to listen to. We do our designs with two coils rather than one because in this day and age, the mono cartridge is going to be used 95% of the time in the context of a stereo system. And if there's only one coil and you try to put it into a stereo system, either you will have to shut off one channel or deal with a large ground loop because the ground will be spread into the left and right channels. So we avoid this by doing two identical coils, one for the left speaker, one for the right, but the signal that they put out is exactly the same. So therefore, we have essentially two mono signals, and this is, as I said earlier, this is really for the purpose of enjoying our mono cartridges on a stereo system.
Okay, next question. This is regarding dynamic VTA and SRA. The Lyra cartridge user guide specified desired setup VTA to be obtained through adjustment of VTF and tone arm base height. Is it assumed that measurement of the cantilever VTA is done with the turntable platter at rest? Will there be a measurable reduction in VTA when the platter begins rotating at 33 RPM? If so, would that reduction have enough sonic impact to justify consideration during dynamic setup of that dynamic VTA?
I would say that the answer to that is yes, because when you put a cartridge on an LP and you start up the platter, you can visibly see that the cartridge squats down a bit due to the forward pulling action of the groove. Now, so the cantilever is at an angle rather than being completely horizontal. So due to the vector, any forward motion must result in a vertical component as well as forward. And so for that reason alone, it almost makes no sense to try to do the setup with the platter not rotating. So if possible, I would strongly recommend that all of the vertical tracking force and VTA adjustments are performed with the record spinning rather than static. Now, back to the mono issue. What we find is that the summing to mono, if such is performed, should be done as early in the process as possible. If there are two stereo channels from the cartridge that are summed to mono in the preamp, then of course there's always the possibility of level differences between the channels, azimuth differences, and so on and so forth. And if that is taken as is and summed into mono, there probably will be a vertical component left over. And so if all of that is done inside the cartridge, even if there's a level difference between the two channels, both are extracting exactly the same signal. So there is almost no possibility of vector conversion errors from occurring, if that makes sense. Okay, so are there, I've really just skimmed over what we do, but are there any questions whatsoever? And for example, we do our own stylus shape. We are the only company that does direct mounting of the cantilever into the cartridge body rather than through an in-between piece, so there's a lot to talk about.
One other question. There was from what I understood, there was a shortage of the boron that
Right.
that you used.
Yes.
And I heard that you were charitable with some other companies and helping them obtain and support even some competitors as well. So that would be nice to hear a little bit more about.
Okay, well, actually, we were the recipients of such generosity rather than being the deliverers of. But it's an interesting story nonetheless. Okay, part of this, I'm not really, I have to piece things together because I don't know all the details. But boron was originally used, I think, in the late 60s and throughout the 70s as a structural reinforcement filament material. I think that the F-14 Tomcat naval aircraft used boron fiber for reinforcement of some of its some of its movable aerodynamic surfaces. But boron is an extremely expensive process material. The raw material is cheap, but the processing is expensive. And it is also not amenable to true mass production. It really wants to be made as a filament. And when carbon fiber was introduced in the late 70s and early 80s by Hercules and whatnot, it was a lot more mass production friendly. And therefore, and it was equally as strong as boron, in a different way, but it was equally as strong. And therefore, the economics really made boron unappealing as a structural reinforcement material. So the demand for carbon kept on increasing, but the demand for boron filament, if anything, decreased. And so borons first started being used in cartridges probably around the mid-70s. I think that Panasonic had some patents on the fabrication of chemical vapor deposition boron. But in other fields like tennis rackets or golf clubs or fishing rods or whatever, boron was pretty much displaced by carbon. And so therefore the total manufacture of boron really seems to have plummeted. I believe that while boron was still in somewhat large manufacture, some of the manufacturers of cantilevers, like Ogura and Namiki and probably Van den Hol, they were able to buy up stocks of boron. And when you make a cartridge, probably the amount of boron that you use in a cartridge is going to be like 15 millimeters, something like that. So a reel of boron is going to go for an awful lot of cartridges. And so it seems that the purchases of boron filament that were made back in the late 1980s served the cartridge industry all the way into the past, all the way past 2010. But the stocks were steadily being deplenished. They were steadily being used up. And so around 2013 or 14, we were told by our two cantilever suppliers, Namiki and Ogura, that their stocks were about gone. And so that we better come up with replacements, and they would suggest that we used sapphire or aluminum in preference to boron. Now, aluminum is not nearly as stiff as boron is, and ruby and sapphire are a whole lot more massive. They're a lot more dense than boron is. So we balked at the blanket suggestion that we move to sapphire. And I would assume that a number of other cartridge manufacturers similarly protested that this was preferably something that we would prefer that Namiki and Ogura put in extra effort to find a modern equivalent. And in fact, I did some research on potential suppliers of boron in the United States, and I delivered those to Namiki, and I suggested that they go look at these suppliers. Despite that, things really pretty much came to a halt. And for a time, Namiki was unable to deliver any more boron cantilevers. And at that point, at least in time, I could see that GECO announced the end of their SAS boron cantilever replacements for cartridges, undoubtedly because their supplies of boron cantilevers were gone. Ogura has always been higher priced for cantilever assemblies than Namiki has. And probably because of that, their supplies of boron lasted longer for us than Namiki's. But still, they told us that, probably within the period of about 2.5 years that we should expect that boron would be gone. And so around this time, Stig met Albert Lukaszek of Benz Micro. And so we've known Albert for quite a few years. And Stig talked to Albert, and he explained the situation because Albert also uses boron. And he asked him, how are you doing with boron? And it turned out that Albert had stockpiled quite a bit of boron wire for his own needs. And he very graciously sent us some from his own private stock. And so that gave us about a year's production worth of Delos cartridges. And in the meantime, Namiki had been looking to install a boron fabrication plant in their own facilities, but due to, I believe, environmental regulation, they were unable to do so. But it seems that they were able to find that one of the manufacturers that I had suggested, a company called, I think, Specialty Materials on the east coast of the United States, they made a similar type of boron with a tungsten filament in the center, but of smaller diameter than you would normally use for cantilevers, for cartridge cantilevers. And so it looks like Namiki was able to convince this company to make their product in larger sizes And so some test evaluations were performed with a couple of the larger manufacturers like Audio-Technica, and those results seem to have turned out well. So now we have Boron again from a new manufacturer, but from what we can tell, there is no discernible audible difference between the old Boron and the new. So we're back on track, so to speak.
Maybe you could speak about, since it's about materials and all, like the different metals you've chosen for the cartridge bodies.
Right.
And then Stig was mentioning having sort of worked for Koetsu earlier, and of course they're known for their cartridges, but they, in some cases, really exotic materials they used for those. I was just wondering if you might shed some light on that.
Sure. Sugano was, I guess that a lot of the cartridge manufacturers in Japan were into high-tech materials. Denon was, Panasonic was, Audio-Technica was, Sony was, etc. But due to budgetary constraints, there were certain materials that were beyond the reach of the large companies who wanted to sell into the volume market. And one of these materials was a certain kind of magnet, which was comprised of, I believe, 70% platinum, and the rest was iron, cobalt, and so on and so forth. And this was called Platiron. The trade name was Platiron. And this was the so-called platinum magnet that Koetsu used in their cartridges, and later we used in ours. And our usage of the platinum magnet was a direct introduction from Sugano of Koetsu to the manufacturer of the magnets. I ended up using the magnets in a rather different way than the Koetsus did, because our designs had different requirements from what he was doing, but still we ended up using the same materials. And the same manufacturer in the late 1980s, they were also doing so-called 6-9 copper wire, which meant 99.9999% pure copper. And this really did sound better than the OCC or the LC-OCC that we were using prior to that. And so we gradually converted all of our production over to 6-9 copper. And again, this was thanks to Sugano-san of Koetsu. So, much appreciation to him. So, that's regarding the magnet and the coil materials. But around that time, these were the so-called bubble years in Japan, where corporate finances were brimming, and the research labs were given license to create all kinds of exotic and wild materials. And one of these was called 5-9 iron. So, this was, again, 99.999% pure iron, which actually is quite a difficult thing to do. And so we bought a couple of kilos of this stuff at exorbitant prices. And we used these for the Parnassus, for the original blue body Parnassus cartridge. So that cartridge had 5-9 iron pole pieces made from non-contact machining processes. It had the platinum magnets. And we later reincarnated that cartridge as the Olympus. We found that in our storeroom we had an inventory of maybe 10 sets of magnets and these exotic pole pieces. And so I always liked the sound of the original Parnassus, so I decided to do a custom body design for those magnets and yokes for essentially my own joy and Stig's joy. And so this was an in-house project for ourselves and maybe a few select friends. But I think that Stig let some people outside of our immediate circle listen to the cartridge, and their response was extremely favorable. So word of mouth kind of marketed the product by itself. And so the Parnassus itself probably went out of production around 1993. And I think that the Olympus occurred around maybe 2003, maybe. So probably, 10 years apart. So everything that I had learned in the 10 years between the Parnassus and the Olympus went into the body design of the Olympus. So it was a much better performer than the Parnassus was, but it still had the essential character of the platinum iron magnets and the iron and the purified iron pole pieces, because this is again one of those things where measurements really don't tell you much about what the essential personality of the cartridge is going to be. The material choice really overrode any of the measurements.
Is there anything new you're working on right now? Any new models or anything that's fit to share? Anything? Let's say anything immediate that's due to be coming. And you can no comment that one if you like.
We got show at CES. How about that?
Stig, what do you think?
Yeah, but it's okay to speak about the little cartridge.
Okay.
I think.
Okay. All right. So, this maybe goes back to our corporate mandate of protecting and preserving our cultural heritage. But up to now, because we've only been able to produce 1,200 cartridges per year, we've inevitably had to deal with a very, very select audience. And this has been a source of sadness for me, because I would like younger people, musicians, people who don't necessarily have all that much income, to enjoy music at a high level. And so one of the projects that I'm working on right now has to do with a cheaper cartridge, but very high tech, using the latest mass manufacturing technologies to create a very high tech cartridge that will combine old world materials with a very high level of manufacturing precision, and hopefully create a cartridge that has a very interesting and unique personality of its own, and yet be affordable enough that people beyond the traditional Lyra base can afford. So our target price would be probably around $1,000, give or take a bit. And this cartridge it's being designed completely by me, but it will be built by a different builder. So therefore, it will not eat into our 1,200 units per year capacity. So therefore, we should be able to offer this cartridge without endangering our supplies of Etnas or Atlases or Scalas or Cleoses.
Will it affect the boron situation?
This cartridge will not be made with boron. This cartridge will be made with aluminum, but because there are certain things that you can do with aluminum that you cannot do with sapphire or boron. So it's not so much a choice of the material itself, it's more what it allows me to do. And so therefore, this time I would like to focus on the unique properties that aluminum brings to the table and try to take maximum advantage of those properties rather than regarding it as an inferior substitute to boron, which to me that's not something that I want to do. Robert?
Has there been any consideration with Lyra with 3D printing at all? Being it makes sort of your own
3D
hybrids in a
printing
way?
is actually not, at least right now, it doesn't seem to be too friendly for mass production because, yes, you can make intricate shapes, but the time spent per piece can be pretty substantial. So, and also there's a limit to the kinds of materials that lend themselves to 3D printing. And the materials that I would like to use for this new project are outside of the realm of materials that fit into the 3D process. So for a reason such like that, I've chosen to use other processes rather than 3D printing, although I do acknowledge that it is a very interesting process together with 3D design and, STL files and all that kind of stuff.
Next question.
As many as you please.
Yeah. And this is something when we got together for lunch back at the Newport show in
Right,
June,
right,
and
last
when we
June.
first
Right.
when we first talked about doing an event like this, and one of the very interesting things that we touched on at that time was this concept of rebuilding cartridges that have had a life already and that you have taken back and rejuvenated and turned into like new again. And so I think that's a really neat thing about owning something that's such a substantial purchase, that it is something that you can keep and rework. So if you could touch on that a
Sure,
little, that would be great.
Okay. Earlier I mentioned that the builder is a key part of the sound of a cartridge. Along with that, I would say the material choice and the kind of construction that is put into the cartridge also has a huge impact on the sound. For example, depending on the material choice, you can take the exact same frequency response and end up with a very different tonal balance just because of the material choice. Another couple of elements that are key to the sound of the cartridge are the suspension wire, the size and the metallurgy of the wire, and how it matches up with the rubber dampers. So this combination is really key to the sound of a cartridge. If you change the damper choice or the suspension wire, the sound of the cartridge is likely to change in a very big way. And I would say that the dampers have more impact over the final sound than the suspension wire does. So when a cartridge is rebuilt, you really want it to use the same suspension wire choice and the same dampers as the original. But on the other hand, though, especially the rubber dampers are kind of a black art. These are something that most cartridge manufacturers that I know of protect and keep very close to their chest. So I don't know of any cartridge manufacturer who is in the business of delivering their tightly guarded rubber dampers to other suppliers or other retippers. So, that's really one where you have to hope that if you deal with a retipper, you have to hope that he has very good ears and a good sonic memory, and what he rebuilds sounds like the original, because without the original parts to use, he's certainly fighting an uphill battle. Maya, was that what you wanted to, So what we do, of course, since we are the origins of our dampers and our suspensions and whatnot, when we rebuild a cartridge, we take it completely to pieces and we rebuild it from the bottom up using all of the original parts that should have been there. So when we redo a cartridge, it's very much like a brand new production of that model using all the correct stuff. And of course, using the original builder as well. One thing that actually I would like to maybe mention is that the Stylus manufacturers, Fritz Giger or Namiki or Okuda, they all have unique quirks in how their diamonds are shaped and how that affects the insertion of these diamonds into the cantilever. So the One thing is the tracking shape, the shape of the stylus part, but the other part is what the shape of the diamond block is and how that affects the mounting of the stylus onto the cantilever. So, I don't have a whiteboard with me, but for example, Giger's method results in a fairly wide and tall diamond block. And the recommended method for installing that onto a cantilever is to cut the cantilever off with square edges, with right angle edges, and to glue the diamond block onto the resultant flat surface. So that method very much depends on the strength of modern adhesives. Namiki, their preferred method is to shave the cantilever front end off at an angle, resulting in a flat surface that will probably be at 90 degrees to the groove when vertical tracking force is applied, and to glue the stylus onto the flat. So both Giger and Namiki assume that the stylus will be glued onto a flat surface. But in Giger's case, the flat surface is at the very front of the cantilever, and the stylus is bridging the distance between the forward part of the cantilever and the groove. While in Namiki's method, the front part is left untouched, but the bottom part facing the groove is shaved off, and the stylus is bonded onto the flat surface. So yes, Namiki also relies on the strength of the adhesive, but vertically at least they're backed up by the rigidity of the cantilever material itself. So it's not quite as dependent on the strength of the adhesive. Ogura is different again. Ogura's styli are presumed to fit into a cantilever that has a slot machined into the forward part. And the stylus is inserted into the slot. So it forms a fork around the stylus, and everything is glued together. So, if you can look at it here, Ogura's method would be like this, with the stylus put in from the front into the slot. It would be glued here, and the groove contact would be directly below it. So with Ogura's method, they do kind of enclose the stylus, and so therefore they are relying on the mechanical strength of the cantilever material to a greater extent than either Namiki or Fritz Giger. But each method brings with it not only strength but different degrees of freedom regarding cantilever alignment. So with Giger's method, because it's flat on flat, there is very little room for adjusting SRA. But on the other hand, that also means that there's very little room for error in applying SRA. With Namiki's method, again, the SRA part is defined by the flat surface that is machined into the front end of the cantilever. But with Namiki's method, of course, since it's flat on flat, close to the groove, there's more freedom for azimuth twisting to occur. And with Ogura's method, since the stylus goes into a V slot or a U-shaped slot in the front end of the cantilever, there's actually more likelihood that the SRA will move around. But because the stylus is confined by stiff edges on either side, the likelihood of azimuth or twisting zenith occurring is actually lower than the Namiki method or the Giger method. So all of these methods bring their pros and cons, and it's not really a question of right or wrong. It's it's what the builder has to deal with, and they have to go with the strengths that their chosen stylus brings with it. So when you talk about style, there is actually quite a bit more involved than just the playing part that everyone focuses on.
One other question. Just in doing setup and looking at the actual diamond, it's when you look at it even under 10x, you start to gain an appreciation for how tiny a thing it is.
Yes.
And when I look at it, I wonder how in the world do they get a grip on something that small to facet it and cut it and make it as precise as it needs to be. And my curiosity is, what are the tolerances of what makes a good one and not, what gets rejected and what gets accepted? So if you could speak to that a little bit.
Okay. First of all, with the more complex shapes that have very thin blade-type edges, there are different grades of diamonds, and for maximum strength, they have to be oriented to the grain so that the hardest surfaces follow the playing surface. And so therefore, the lower grade diamonds kind of select themselves for conical and elliptical use, because their broader surfaces means that their playing surfaces are not going to see so much concentrated forces, while the thinner edges of the higher priced exotic styli require higher grade diamonds simply because of the fact that their edges are much thinner. So that's one choice. Regarding the shaping of the stylus itself, the stylus block is inserted into a larger block of metal, which secures the diamond in place, and the entire thing is shaped as one. So the stylus shape is kind of a follow-through of the overall shaping that extends into the metal part. So it's not just the stylus part that gets shaped. Entire block of an entire chunk of metal is shaped, and after the metal is dropped away, and you're left with the diamond stylus. If that,
Wow, I didn't know. That's interesting.
yeah. It's probably if you were to try to, for example, the smallest diamond is probably going to have a cross section of 0.06 millimeter by 0.06 millimeter. So how are you going to secure that in place? And you don't. And the answer is you don't. You insert it into a larger metal piece that secures it firmly, and then you shape everything all at once.
Any other questions, anybody? Okay.
Right then. Thank you very much.